Hello everyone, my name is Tim Kowalski. I'm the Application Support Manager for Wirtgen America and Hamm rollers. My territory is all of North America, so I get to see a lot of different things when it comes to compaction. What we're going to talk about today is compaction basics. So let's get started. When we talk about some characteristics of asphalts, there are some things that we really need to know. There's a lot of different types of mixes that are out there in North America, and I've seen a lot of different types. We have different gradations, we have coarse, we have fine, depending on what kind of materials we're working with, different types of binder that we use. We have polymer modified, we have rubber modified, we have knead asphalts, we have warm mix, a lot of different types. There are some other things that will affect us what we're trying to do when we're trying to pave, like temperature, wind, whether it's overcast or sunny. And when we talk about temperature, there's three temperatures we need to worry about. We've got the base, the mix, and the air. One of those three we can control. That's the mix. The other two are up to Mother Nature, and hopefully they won't change too much from morning, noon, and night. Another big thing that affects our compaction is the coarse thickness. If we don't have consistent thickness, we're not going to have consistent compaction. So it's very important that we have a smooth surface that we're putting mix on top of. So when we talk about the compaction system, it is really broken down into two different systems. One is just static, where it's just the static weight of the machine, and the other one's dynamic. And dynamic we can break into two different sections. One with vibration, and the other one is oscillation, and it's a mechanical induced way of looking at getting compaction other than just using static weight. We're going to talk a little bit about roller trains, and they will vary depending on where you're at in location. But this is an example that roller train is anything that follows the paver. It could be one roller, it could be two rollers, it could be three, it could be 10 rollers. It doesn't matter. Now this screen I'm going to spend a little time on because there's a lot of things that are important. One thing is with the breakdown roller, which is our first roller following the paver, we want to achieve as much density as possible with that roller, but we don't want to achieve it all. If we try to achieve it all, he's not going to keep up to the paver, and the other rollers in the roller train are going to be sitting around doing anything. So it's very important. We're going to start with this machine called a paver and the screed. We need to make sure that the vibrations put on the screed there so that we get a more evenly dense material coming out of the back of that screed. It helps seal the surface a little bit. It'll gain us a little bit density, probably 1 to maybe 3%, and that's 1 to 3% that the roller train does not have to worrying about. So the breakdown roller, if I have this specification of 92 to 96%, if I can achieve 90, 91% with my breakdown roller, I'll be pretty happy because I'm sure there's going to be enough temperature in that mix where the other rollers will be able to gain the additional compaction. That way, my breakdown roller can keep up with my paver. The other rollers, we're probably going to gain either 1, maybe 2%. Finish roller, as the mix gets colder, probably more like a 0.5%. Now I've also got distances down here listed below. And those distances represent the length of each pass of that roller. And they will vary depending on the size of the roller, the speed of the paver, the speed of the rollers. But what I want to make sure is that they're not too long and they're not too short. If they're too long, then we're concentrating too much on one side of the road and the other side of the road is going to cool off and we're going to have a hard time getting density. If they're too short, that means we're crisscrossing too much in our start and stop of our rolling pattern, and if we don't vibrate through that, we're going to have lower densities in that areas, and that could affect our rideability as well too. So it is important to maintain consistency when it comes to our roller length. Now, roller trains are very flexible. Depending on the specifications of the state, this is pretty much typically what I see in most of the locations I go around is where we have a dual steel drum breakdown roller, a rubber tire roller in the middle, and then a dual drum in the back running finish roller. And that's going to probably run static because by the time the temperature gets that low, we don't want to use vibration because if we use vibration in a cold mat, we're just going to start breaking rock, and we don't want to do that. Now there's some key design specifications that affect compaction. We're going to touch on some of them. We're not going to get through all of them, but there's some things we need to look at. We're going to talk about amplitude, we're going to talk about frequency, and sometimes people get amplitude and frequencies switched around, and hopefully we can get that straightened out. We're going to talk about static weight, the weight of the machine. We'll talk about centrifugal force, and probably the biggest misconception of centrifugal force is everybody thinks the higher the centrifugal force, the better compaction I'm going to get. That is not true. It's understanding how to control that centrifugal force for what kind of compaction you want to achieve. We'll talk about roller speed, and roller speed is going to tie directly into frequency. And those two things tie into what's called impact spacing. And impact spacing is very important not only to get consistent compaction, but also to get rideability. Drum diameter, we'll talk about drum diameter, how that affects what we're trying to do as far as compaction goes. A lot of people don't think about it, but it does have an effect on what it is that's going on. Drum activation controls, the newer rollers now have individual drum controls, so we can control each drum individually and set them up differently if we need to. Years ago, it was either all on or all off as far as vibration goes, and we didn't have any control of individual drums. Water and scrapers, two most important things on an asphalt roller is the water system and the scrapers. The two most neglected things on an asphalt roller is the water system and the scrapers. Very important. If we don't have a good scraper system or water system on an asphalt roller, we're probably not going to be using it on the pavement. And then drum offset, just going to say that not every manufacturer has that, but it's probably the most underutilized function that we have standard on our machines. But it takes some getting used to, but it does have a lot of benefits with it. So when we talk about amplitude, we're talking about the size of the weight that's swinging around inside that drum. We have every manufacturer set up a little bit differently. Ours are set up with two amplitudes, a high and a low, with a variable frequency. Other manufacturers might have multiple amplitudes and set frequencies. And all amplitude is basically how much weight is swinging around that center axle. Ours has a swinging weight, sliding weight inside this cavity. So if I go counterclockwise, the weight swings away from the stationary weight, and I have a much smaller weight spinning around that axle. So with a smaller weight, I can spin it faster. So the speed is the frequency, the amplitude is the weight. If I rotate it the other direction, the weight slides down to the where the stationary weight is, and I have a heavier hammer swinging around that axle. So with a heavier hammer, I can't swing it as fast. So my frequency is going to be less, or my speed is going to be less. But I have a much heavier or a higher amplitude there. Now, a lot of states require most manufacturers to have some kind of a startup guide or setup guide for each of the rollers, depending on the size of the roller and the thickness of the mat that you're trying to compact. So we have one set up that whichever roller you decide to choose, it'll give you an idea what kind of settings we look at to get you started with that machine. Now next, what we're going to go into is our roller speed and our frequency. I mentioned that before, roller speed and frequency tie into a thing called impact spacing. In this example here, we have a roller that's traveling 3 miles per hour, and it's running at a frequency of 3,200 VPM. That's vibrations per minute. So every time that drum hits the ground, there's a spacing in between each one of those. But down below you can see that that spacing is 1 inch. So in 1 foot, I have 12 impacts. So it's 12 impacts per foot. That's a very key number to remember. I always tell people, I said, if you run between 12 and 16 impacts per foot, I don't care whose roller you have, as long as you got temperature in the mix, you should be able to achieve density and achieve rideability. So let's move on to the next example. Now we take that same roller, the same frequency, only we go from 3 miles per hour up to 4 miles per hour. So now my spacing, instead of that 1 inch or 12 inch impacts per foot, now we're down to 9 impacts per foot. We start dropping below 10 impacts per foot. We're going to start putting raveling into that material. And what that means is, if anybody knows what IRI is, that's an International Rough Index. That's how they measure smoothness of pavements. If you start running below 10 impacts per foot, that will actually start showing up in the IRI results. And you do not want to do that. So 12 to 16 impacts is very key. And this chart here in a standard vibratory roller, which is 3,000 VPM, it'll show you that where about 12 impacts per foot is, we're about 2.8 miles per hour. Now, if you look at a high frequency roller that goes around 4,000 BPM, that 12 impacts per foot is about 3.8 miles per hour. So with the higher speed of the paver, we can use a higher frequency roller and gain a little bit more speed, but still maintain our impact spacing so that we're not building problems into the roadway. We also have these magnets that show impact spacing as well too. And on the left-hand side is the frequencies. Up on top is the impact spacing, and then all the numbers in the middle are your speed. So for example, the 3000 VPM, we run over here, it's 2.8 miles per hour. That's 12 impacts per foot. The 4000 VPM, 3.8 miles per hour, 12 impacts per foot. So this will fit on any roller. It doesn't matter what make or model because we're only tying it to speed and frequency. It has nothing to do with any other settings on the roller. Because the last thing we want to do, is build any kind of bumps or ripples in the mat that's going to affect our rideability or our compaction effort. Now, one of the other things that's very key to remember is temperature. We want to make sure that temperature is always in a good spot for us to get compaction. Rule of thumb, too, that's been in the industry is anything under 175 degrees Fahrenheit, we usually want to stop running vibration. Now, that will vary depending on the type of mix and the lift thickness and the oil that you're using in the mix. Typically, what I tell people is you can usually hear it from the roller. When you start hearing the drums tinging on the mat using vibration, then you know it's starting to lock up and we're probably going to start breaking rock. Or if you feel the machine starting to move sideways on you, then you know that it's starting to lock up and we're going to need to shut the vibration on. But the other thing, temperature is your friend. Usually if you can't get density, usually a lot of times what I tell people is give me 10 more degrees coming out of the back of that paver and I'll probably have a better chance of getting compaction. We also want to make sure we have the right size roller for the project. I know sometimes you don't have control over that, but we want to make sure we have a big enough roller to get the compaction we need, but a small enough roller to be agile enough to get in and out of places without tearing or destroying the mat. Now I showed this slide before only with densities. Now it has temperature ranges because each roller is going to have a certain temperature range. These are typical numbers that we see for just normal mixes. If we had a polymer modified mix for the breakdown roller, this upper number might be 330, 340. If we're running warm mix, the upper number might be 260, 270. But each roller is going to have a range that it wants to stay within and run the same pattern for consistency. That way we can get our numbers. There are some things that actually can affect this as well too. I talked to you before, mat lift thickness. We start varying the mat lift thickness, we're going to start varying our compaction effort. Our ambient and base temperatures, we know those are going to change, but we don't have any control over there, but we know they're going to change from morning, noon, and night, and we can adapt to that. The only thing that we can control is the laydown temperature, the temperature of the mix coming to the paver. That's what we want to make sure stays consistent. And with wind velocity, a small 5-mile-an-hour wind can actually cool down that mat pretty quick. So we just want to make sure that we're aware of that. 10 commandments of rolling. First one, we want to roll as close as possible behind the paver, but we do not want to hit the paver. The closest that roller needs to come to the back of the paver is the length of the roller. That way you're staying consistent in your rolling pattern and you're not slowing down, running static, and wasting time. I want to be very consistent in my rolling pattern. We always want to start on the lower edge. At least I like to start on the lower edge and bring all the material up to the joint so we're working against gravity. And then we'll talk about joints later. The only time I compact a joint first possibly is if it's next to a hot mat already, so we're paving an echelon, or if we're paving next to a lay that's just been laid as well too. We want to make sure we deactivate vibration before reversing, because we don't, we're going to build some bumps in that mat that we're not going to be able to get rid of. So when you shut your vibes off and you go into your turn to stop, the furthest you need to go is a length and a half of that roller to stop after you turn the vibes off. And then as soon as you go in reverse, start the vibration back up again. We always want to change the rolling speed gently. Smaller rollers, you still have control of that speed with the F&R lever. With the bigger rollers nowadays, we actually build in a coast factor so that when you're going forward and you slap it in reverse, it'll still coast a little forward, but then it'll back up. So it has a slower transition from start to stop. We want to move forward and backwards in the same track, only not exactly in the same track. We want to move over just a couple inches so we're not cutting that mat with the dual edge of the drums on either side. So we want to move over just a little bit. We're going to change the roller track on the cold side or the beginning of your pass. We don't want to change the track up there by the paver unless you can totally get 100% off of the pavement. Rolling parallel tracks next to each other. I don't want to see any zigzagging around. The more and more we have a tendency to turn on the mat, the more tendency we have to tear the mat, and we don't want to do that. We want to water the drums sufficiently. We only need enough moisture on the drums to keep from picking anything up. Anything more is a waste. Now, every manufacturer has a water management system, and we just need to control how much water we're putting on our drums so we're not overwatering and pre-cooling the mat. Never want to leave the roller on the hot mat. If you come to a stop and you want to park in the paver stop, don't stop right behind the paver. Either get off the mat onto a cold mat or go back to the beginning of your pass and park there. Let the other rollers go around and finish their rolling until we move on again. There's three more. One more is we want to make sure our eyes are on the drums and the water system to make sure that the water is covering the drums sufficiently and we're not picking anything up on the drums. We also want to make sure that we're not running anything over, so we need to be aware of what's in front and behind us as well too. It's all about being consistent. Because if we're not paying attention, we might end up like this guy. So after finishing, we want to park the roller in a secure, out-of-the-way place off of the roadway so this does not happen. We hate to see that. We want to make sure everything's off in a safe distance off of any kind of a roadway so that we can be safe and get home. We want to inspect the drums and scrapers. We want to make sure that we inspect the water system. We clean the filters. The scrapers, we want to make sure they're in the proper position. If you're going to be traveling down the road, make sure they're off of the drums, because if the scrapers are on the drums and you're traveling down at high speeds, they will burn out pretty quickly. And if you happen to forget, at least hit the water system a little bit, cool it down a little bit. Most all manufacturers now have some kind of a antifreeze flushing system, so if you're in an area where it might be freezing overnight, you can actually run the system through and set it up that way. Pick up and move the trash and belongings. Older machines had a manual battery disconnect switch. The newer ones do not, because we have the DEF fluid. When you turn the key off, the DEF fluid pump pulls all that material back through the lines, back into the tank, so it doesn't crystallize in the lines and derate the engine when you least expect it. So there are some key factors affecting rolling patterns that we're going to talk about. Just basic rolling techniques. Paver speed. Paver speed, a lot of people think dictates the speed of the rollers. It's really the speed of the rollers really need to dictate the speed of the paver. Number of passes, and number of passes is different than number of coverages, but going back to number of passes, everybody's idea of a pass count is a little bit different. We'll go through that as well too. And we'll talk a little bit for joints and edges as we finish up. So again, never want to stop the roller on a soft mat, whether it's standing still or vibrating, because we're going to put dimples in the mat that we're not going to be able to get out. We also want to make sure we overlap at least 6 inches from one pass to the other pass. And the reason why is because there's a little bit of a bow wave on either side of the drum as we roll. And if we don't overlap that, that's loose material. And if we roll on top of it, it's going to create a tear line. So we want to have at least a minimum of a 6-inch overlap every time we do that. We also want to make sure we never stop straight on behind the paver. We always want to make sure we stop on an angle. And the reason why is because it'll be a much easier chance to get the bump out. This video shows just a lump of clay and a baker's roller. It's showing that if we stop straight on and we try to come straight back through, that's a bump we'll never be able to get out, because of not only the compaction difference, but the temperature difference as well too. So if we take that same lump of clay and the roller and we stop on an angle, even if we come straight through it, we have a much better chance of rolling out. Even though we have a temperature and compaction difference, we have a much better chance of squeezing that bump out and having a smooth ride. Now when it comes to number of passes, this is my idea of a pass count. Anytime the roller is going in a direction, it is creating compaction and density. If it comes back in that same track slightly over a little bit, that's a second pass. So up and back is 2 passes. There are a lot of locations I go to that up and back is considered 1 pass. So just definitely be aware of that. They maintain these patterns for consistency, and every time you go up to the paver, you're going to do it to the same distance and same number of passes so we can get more consistent density and rideability. All these passes, the way up and back, if it's 2 passes, it's going to have an odd number. So your odd number is always catching you back up to the paver. Each roller is going to have its own set of pass counts to keep behind the paver. Number of coverages is a little bit different. Number of coverages is basically how many times will the width of my roller cover the width of the mat that I'm paving. So I can have a 2-pass coverage with a 9-pass pattern. This one here shows an example of where we are changing track on the cold side of the mat or the beginning of our pass to catch back up to the paver. This one here is an example. If I have a 5-pass pattern, my last pass I want to take to catch back up to the paver, most people say they want to go down the middle. I don't like going down the middle for a couple of reasons. If you go down the middle, when you get to the end of your pass, you either got to turn up or you got to turn down. Well, turning on the hot mat is not a good thing because you can tear the mat. The other thing too is the outside edges of those drums actually run right in the wheel pass, and that has a tendency to bring up a crack once you start putting traffic on it. So what I always tell people, I said, run at the bottom first, or if you want to pinch the joint first, that's fine too. But if you run on the bottom here, you just keep going right straight into your next set of passes and do the same thing as you're following the paver. Now when we talk about joints, a lot of different ways we can compact joints. There's a right way and a wrong way or the bad way. This way that I'm going to show you is one of the most successful ones that I've seen. And I've always told people I can always tell when I drive down the road which side of the mat was laid last by the side of the joint that fails first. So here's an example where when we get up to the joint, whether it be initially or when you're going from the bottom up, stay 4 to 6 inches off of that cold joint. Both drums, if it's a dual vibratory, are going to be vibrating up towards the paver. When you come back and overlap that 4 to 6 inches, you're going to run static. Most people like to run vibration. The problem with vibration is all that force goes into that cold joint, and that's what breaks up that cold joint. This is an example of how that looks. Once that roller compacts that mix down to the joint, all the force of this machine goes into that cold side, and the cold side of the joint is what breaks up. Not only that, all that pressure, now that we're bridging here, has to bridge somewhere else. So now it's on the outside edge of that drum, which is in the center of the lane, and now it's actually going to have probably a crack down the center of the lane as well too. So we don't want to do that. Now if you have oscillation, and I didn't get into a lot of detail about oscillation, but oscillation is not vibration, and it's not going to hurt the joint. So you can have vibration on the front drum, oscillation on the rear drum going towards the paver, 4 to 6 inches off of that joint. When you come back, you turn the vibration off, but you leave the oscillation on. The oscillation is not going to ruin that joint because it's not vibrating on it. It's skipping across the surface back and forth, and it's not going to destroy it. So what it does, it actually kneads that material into that cold joint without destroying the cold side because it's not crushing any rock. We're still going to have a little pressure on that outside edge, but nothing like we would if we had using vibration. So with that, I thank you, and hopefully that brief compaction basics is going to help you out. And there's a lot more to do. Hopefully this will get you started, and I appreciate the time. Thank you.